This is question 1 from the topic on extraneous and confounding variables. The definition of an extraneous variable is all variables other than the independent and dependent variables that might affect the results of the experiment. So all variables that are outside of the focus of the study that might still affect the results are extraneous. If I'm assigning 50 people to watch a video on helpfulness and 50 people to watch a random TV show, and I ask everyone how much money would they donate to charity, the independent variable is the type of video watched because that's what I'm manipulating. I'm randomly assigning people to watch different types of videos. The levels of the independent variable are the two specific videos that I have them watch, which are the video on helpfulness and the random TV show. The levels are just the specific conditions that are being used. The dependent variable is the amount of money offered to charity because that's what I'm measuring as my outcome to see if the independent variable had an effect. So it's A is correct. Well, in this study, we're looking at the effects of the video on the effects of the type of the video on the amount of money donated to charity. Gender, income, and age are variables that might affect the amount of money donated to charity, but they're not within the focus of our study. They're not, so since they're outside of the focus of the study and they're not independent or dependent variables, they're extraneous. They might affect the results of that experiment, but the independent variable is the type of video watched, and the dependent variable is the amount of money that they said they would donate to charity. And these other things are not the independent or dependent variable, but they could still affect the results, which means that they're extraneous. So the researcher manipulated age, gender, and income to look at the effects of those things on helpfulness. That's not correct. We didn't manipulate age, gender, and income. If we did manipulate them, they would have been independent variables. What's actually correct is we didn't manipulate these things. We only manipulated the type of video that they watched. And we're actually not interested in looking at the effects of these things on helpfulness. They're outside of the focus of our study, but they still might affect the results, which means that that's why they're extraneous variables. So that's why you would have chosen, this explains why you would have chosen extraneous as the answer to question 3. So why was it an experiment? It was an experiment because we were randomly assigning people to groups. Just because a study takes place in a lab doesn't make it an experiment, because you could have people come into a lab and just fill out a questionnaire without any manipulation. And you can also compare groups of people in a non-experimental study, because you could do a study comparing men and women and that study wouldn't be an experiment. So It's only an experiment if you randomly assign people to the groups. Extraneous variables are not always confounding variables, because if the two groups of participants in your study are equal on an extraneous variable, then that extraneous variable is not a confounding variable. It's only if the two groups are different on an extraneous variable, that's the only time when that extraneous variable becomes a confounding variable. So an extraneous variable might or might not be confounding, depending on whether the groups of participants are equal. So a confounding variable is an extraneous variable that's unequal across the conditions of the experiment. I've been using the word groups a lot in this video, but remember, if it's a between subjects design, groups and conditions are the same thing, because group 1 gets condition 1, group 2 gets condition 2. So if it's a between subjects design, I could say unequal across the groups or unequal across the conditions, because it has the same meaning. So an extraneous variable that's equal across the conditions is extraneous, but it's not confounding. But if you have an extraneous variable that's not equal across the conditions, it's both extraneous and confounding, which is A. Let's see if I can blow this up a little bit. If 50 people watch a video on helpfulness, and 50 people watch a random TV show, and it's that same experiment, and I ask everyone how much they would donate to charity, if the group of 50 people who watch the helpfulness video is these three things: 30% female, mean income of 40,000, mean age of 23, and the other group of 50 people who watch the random TV show where 30% female, have a mean income of this amount and a mean age of this amount, then, well, gender, income, and age are the three extraneous variables because they're outside of the focus of the experiment. The focus of the experiment is just looking on the effect of the video on helpfulness. So we have three extraneous variables. Gender is not confounding because the two groups have the same number of females, same percentage. Income isn't confounding because the two groups have equal incomes or equal average incomes, so that's not confounding. But age is confounding because the two groups are different in age. One group is older than the other group, 23 and 35. So we have gender is extraneous but not confounding. Gender is extraneous but not confounding because the groups are equal on gender. Income is extraneous but not confounding because the two groups are equal on income. Age is extraneous and confounding because the two groups are different in age. So it's D. Now I'm doing an experiment on calorie intake, the effects of exercise on appetite. Half the people are assigned to exercise, and half are assigned to exercise. There was a little bit of a typo. It's half are assigned to exercise, half are assigned to not exercise. I record each person's calorie intake during the day. The average intake of the exercise group is higher than the average of the no exercise group. And I interview the participants at the end of the study. I find out that the participants in the exercise group ate less food in the morning, or less calories, and the participants who were in the no exercise group ate more calories. So which of the following is correct? Well, the independent variable is the exercise or amount of exercise, because the different groups are being assigned to different amounts of exercise. And the dependent variable is calorie intake, because that's what I'm recording as my outcome. And the confounding variable is calorie intake in the morning. So which one is that? Amount of exercise. Well, I'm looking at the effect of amount of exercise on calorie intake during the rest of the day following the experiment. So that's actually my dependent variable. I want to know if exercising will make them eat more during the rest of the day. But the two groups, the exercise and no exercise group, eat different amounts of food in the morning, which is a confounding variable, because now I don't know for sure why the exercise group ate more food than the no exercise group during the study. It could be that the exercise group ate more because of the exercise, or it could be because they didn't eat much breakfast, or it could be because of both reasons. So actually, the amount of the food intake in the morning is a confounding variable. So it's actually B. I'm looking at the effect of the independent variable of amount of exercise on the dependent variable of how much the participants eat during the rest of the day. But it turns out that the two groups also ate different amounts of food in the morning, which means that the two groups are unequal with each other on this extraneous variable, which makes it confounded, and it throws off my conclusion. I can't make any conclusion at the end of the study. I want to look at the effects of exercise on appetite. I'm doing the same study. It looks like I get the same results. And it's still confounded because the two groups, the exercise and no exercise groups, ate different amounts of food in the morning. So the two groups are unequal with each other in a way other than my manipulation, which makes it confounded. And since it's confounded, there's more than one possible explanation. It could be that the participants in the exercise group ate more food, because of exercise. It could be that they ate more food because they didn't eat much breakfast, because they had less food in the morning, or it could be because of both reasons. So all of these are possible. It could be that the participants in the exercise group ate more food, and that exercise was the only reason. It could be that they ate more food because of having less food in the morning, and that's the only reason. Or it could be both reasons. It could be that the exercise made them eat more, and not eating breakfast also made them eat more. So it's actually A, B, and C could all be correct, or any one of these could be correct. So what this is getting at is that when you have a confounded experiment, it could um, it could be that you have an effect of the independent variable, an effect of the confounding variable, or an effect of both the independent variable and the confounding variable, and you don't know which of those three possibilities is correct. This is the same scenario over again. And since it's a confounded experiment, we can't conclude that the participants ate more food because of the exercise. We can't conclude that the exercise is what had an effect on the appetite, because it could just be that the people in the exercise group ate more because they didn't have as much food that morning. So we can't make that conclusion because the experiment is confounded by the food intake in the morning. Exercise isn't a confounding variable because exercise is what we're manipulating. Exercise is actually the independent variable. Food intake in the morning is another difference between the two groups of people other than our manipulation of exercise. And whenever the two groups are different from each other in any way other than your manipulation, you have a confounding variable. Um, Here we have the same experiment, but this time um, I have a rule that all participants have to eat the same exact amount of food on the morning of the experiment, which means the two groups are now getting the same amount of food in the morning. And it's saying, now can I conclude that the exercise had an effect? Um, so yes, I now can conclude that the exercise is what had the effect, as long as there are no other confounding variables in the experiment. I made it so that food intake in the morning is no longer a confounding variable, because now the two groups are equal. They have equal amount of food in the morning, so it's not confounding anymore. So like that, I can now make the conclusion that I want to make, as long as there are no other confounding variables. Um, if you have a confounding variable, it lowers the internal validity of the study, because um, it prevents you from making a cause and effect conclusion. It prevents you from concluding that the independent variable had an effect on the dependent variable. If you have a confounding variable, you have low internal validity because you can't conclude that the independent variable is what had the effect on your dependent variable. Um, Now I'm randomly assigning people to get different amounts of sleep. And I give everyone a task the next day and I count the number of errors that they make at the task. The people who slept 4 hours had less food in the morning, and the 50 people who slept 8 hours ate more food in the morning. So I'm manipulating hours of sleep because I'm randomly assigning people to get different amounts of sleep. So hours of sleep is my independent variable, and the two groups are different on something else besides my independent variable. The two groups are also eating different amounts of food, which means that food intake becomes a confounding variable. And since it is confounded by food intake, well, what's going to happen is that in my experiment, I'm expecting the 50 people who slept 4 hours to do worse at the task because of not getting enough sleep. But now it looks like the 50 people who slept 4 hours also didn't eat very much food, which means that they'll do even worse. Which means that the difference between the two groups will end up getting bigger because we have one group that had a full night's sleep and a good amount of food, and another group that didn't get enough sleep and also didn't get enough food. So what that's going to do is it's going to make the two groups, it's going to make it's going to make the difference in performance between the two groups even larger. So studies confounded by food intake, and the difference in performance between the two conditions is likely to be larger than it would have been otherwise. Now I'm back to that study on exercise and appetite. Now it's confounded again. But now what we have is the people in the exercise group ate less food in the morning, and the people in the no exercise group ate more food in the morning. So it is confounded by food intake again. We have to think about how this is going to affect the results. Well, what we were predicting is that the exercise group would eat more food than the no exercise group. But if the people in the exercise group ate less food in the morning, that's going to make them more hungry. So what it's going to do is it's going to make the people in the exercise group eat even more, and the people in the no exercise group ate more food in the morning, which means they'll be less hungry and they'll eat less. So the difference in food intake will become even larger. So it's B. Um, what are we doing now? Now the participants in the exercise group ate more calories, and the people in the no exercise group ate fewer calories. So what's that going to do? Well, the people in the exercise group, if they eat more calories, they're less hungry. And if the people in the no exercise group eat more, I mean, if the people in the no exercise group ate less in the morning, then they're more hungry, which means that they eat more. So the difference between the difference in eating will become smaller because of the confounding variable. If I ask all participants to sit exactly 3 feet from the screen, I'm controlling the distance from the computer screen, because when you make sure that something never changes throughout the experiment, that's control. Here what I'm doing is half of the people go to group 1, half go to group 2. In group 1, 25 are tested in the first week, 25 are tested in the second week, so it's half and half. And in group 2, 25 are tested in week 1, 25 are tested in week 2, which is half and half again. So we're using balancing. We're balancing the week that we're testing people in. So balancing is being used. And random assignment is also being used because I'm randomly assigning people to group 1 and group 2. So it's random assignment and balancing. If you control variables, that tends to make the experiment less like the real world, because um, when you control something, what you do is you make sure that that thing never changes. And for example, if you're controlling the noise level, you would make sure that the noise level never changes. Or if you're controlling temperature, then you would make sure that temperature never changes. But in the real world, um, things like noise and temperature do change. So if you control them, you're making the experiment less like the real world. Um, random assignment will make the two groups about equal on personal characteristics. Not exactly equal, but somewhat equal. So its random assignment will make the two groups roughly equal on all of the personal characteristics, which are gender, age, IQ, and income. But random assignment won't make the groups. Random assignment won't affect the time of day that they're tested at. Um, so if I want the two groups to be tested at the same time of day, I have to do that with controller balancing. Because it's possible for me to randomly assign the participants to the two groups, um, and for me to still end up testing them at different times of the day. So if I want to make sure that they're tested at the same time of day, I can't count on random assignment making that happen. Um, Random assignment will only make them equal on personal characteristics that they bring into the study with them. Okay? And B isn't correct because random assignment doesn't make the groups exactly equal on personal characteristics like gender, age, IQ, and income. It only makes them roughly equal on personal characteristics. And that was the last one that we covered.